Hello, good afternoon, everybody. This is Dr. Mahmoud from North Carolina A&T State University, and I'll be with you today presenting this paper, Identifying Information Superspreaders of COVID-19 from Arabic Tweets. This is a list of authors who helped me in this paper, and I'd like to thank them all. So this is my agenda for today. I'll start with introduction, then I'll cover some of the related work, then I'll introduce the experiments, result and discussion, conclusion, and future work at the end. So this paper is on coronavirus. And as you know, coronavirus has affected people across the globe with more than millions of confirmed cases. It started in 2019 and still affected us up to now after 2 years. On the other hand, influencer or super spreaders in social media can contribute to the spread of misinformation about the COVID-19. For example, maybe one person report the number of cases in one of the countries exceed 100,000, and maybe this is false information, and we would like to verify this piece of information. Is it coming from a trusted source or not? So in our study, we used Twitter because it is a well-suited platform. It has more than 300 million active users, and that's why we think it is a good candidate to be used in our study. So we investigate the problem of finding super spreaders of COVID-19 information on Arabic Twitter by applying several graph ranking algorithms to rank user influence. So our work compared to other work in literature, we are different from most of the existing techniques because most of the existing techniques are dealing with English language, as you can see, but we are dealing with Arabic language. Also, our study covered a period of 31 days, unlike other studies that are very recent also, and it covered a short period. Also, we have used different graph ranking algorithms in our study, like centrality metrics, hate algorithm, page rank algorithm, vote rank, key shell, and WCI algorithm. Unlike other studies, they have used maybe one centrality metrics or some heuristic rules to find the influencer or super spreaders. Also, we have considered different type of interaction in Twitters, like retweet, reply, quotes, mention, unlike other works that have only used some of these interactions. As a result, we have been able to identify multiple accounts, multiple types of accounts, not just citizen accounts, as super spreaders, like government accounts, celebrities account, and so on. Other works have only identified some citizen accounts as super spreaders. Also, the number of users used in our study is pretty high, more than 500,000 users, so that we think our work is unique compared to existing techniques. So what is the proposed framework? We have used Twitter, as I mentioned. So Twitter is a social network and normally can be represented as a graph with N vertices and E edges. As you can see here, this is a simple graph for Twitter. These are the number of users, and the edges here can be of any type. So I can have an edge between this person and this person if this person is following this person, or this person is liking this post. So there is an edge between this person and the post, and this person is the owner of this post, and so on. We can have different type of graphs according to these edges. So behavioral networks, as a summary, are ideal for studying the role of influencer in information dissemination. And by behavioral network, I mean these edges can be the retweet edges, the mention, the quotes, and so on. So we have applied different techniques after constructing graphs on Arabic data. These techniques are summarized as follows. So the first technique is page rank algorithm. So page rank is a well-known algorithm developed at the early stages of Google search engine. Also, it is defined as page rank because it used to rank pages on the internet. So the rank or the importance of the page is defined recursively and depend on the number and page rank metric of all the pages that link to this page, so the incoming link. So if this page is important, this means the incoming links are coming from important pages, and so on. So it is a recursive relation. Hyperlink induced topic search is very similar to page rank. Also, it defines a recursive relation, but it uses hubs and authorities. These are special types of pages to define the recursive relationship between web pages. The third metric we used in ranking nodes in our graph is centrality metric. So in centrality metrics, the importance of a node varies according to different types of metrics that we will define now. So the first one is degree centrality. So it is simply count the number of edges that's attached to a node. The more the number of edges, the more the degree, the more importance the node. Second is the closeness centrality. So a metric that counts the average distance of a node to all other nodes. So if the node is close to most of the nodes in the network, it will be very important. And this is usually used in communication networks, because closeness can be productive in communicating information among the nodes. The other centrality metrics is betweenness centrality. This metrics measure how often paths between nodes must traverse a given node. Okay, so if we would like to move from node A to node B, we will pass through different nodes. So the more you have paths through a certain node, the more importance this node. Then the K-shell algorithm. Also, it is another metric. So the more important is the location of the node in the network. So the nodes that are in the core of the network, in the middle of the network, are more important than the nodes in the boundary of the network. Also, we have used vote rank algorithm. It computes a ranking of a node based on a voting scheme. So if we need to select or to know which node are super spreaders, every node has to vote in turns. And the node getting the most vote in each turn is regarded the most influential node in that turn and will be elected as one of the top influential spreaders. So the technical details of this algorithm are skipped from this presentation. So the final algorithm we used is the weighted correlated influence measure, WCI. It is a new algorithm designed specifically for Twitter. It takes into account some features associated with Twitters, like the retweets, the follow, and the several features already offered by Twitter. So the data collection, we collected a data set with more than 4 million tweets from March 1st to March 30 in 2020. And we created a list of the most common Arabic keywords associated with COVID-19 to collect the tweets. So after the cleaning and removing duplicate tweet and tweets that are not in Arabic, we ended up with 1 million tweet out of the 4 million. And the number of users, as I mentioned, is around 500K. And the number of verified accounts is around 4,900. And the number average follower count is 4,700. So we removed all the tweets that are written in language other than Arabic from the 4 million tweets. And also duplicates tweet were removed as pre-processing. And the fields such as retweeted by, mentioned by, quoted by, replied by were added so that we can construct the graph in a valid way. Then we used Python library network-X to construct a graph. It is a behavioral graph. So the nodes are the accounts, or the vertices are the account, and the edges are the relation like mention, retweet, quote, and reply. And edges is a set of weighted edges that represents the dynamic interaction between user, which can be retweet, mention, reply, and quote, as I mentioned. And we gave retweet and quote higher weight because we think that retweet and quote are more influential on social media, unlike mention and replies, because mention and replies appear only to the users that I mentioned or replied to. However, retweet and quote appear to all my friends as a user. The result after creating this graph is a directed weighted graph where every edge is annotated with a weight that represents the interaction weight. In our analysis, we classified the accounts into 2 categories, individual and organizational account. And to investigate how the measures, the algorithms that we used are correlated, we used Spearman's rank correlation coefficient as a measure to see how all the algorithms that we used are correlated together. So in this table, we show the correlation between the 8 metrics that we used, A, B, C, D, E, F, G, are the metrics that we used, and the correlation between them. So from this table, we can see, for example, A and C have a positive correlation. A is a PageRank algorithm, and C is the n-degree algorithm. This means, this positive correlation measure means the top influential account found by these two algorithms are very similar. Also, A and H have a positive correlation. A and G have a positive correlation, and so on. The negative correlation means these two metrics find different accounts in the top 20. For example, I think K-shell, WCI, and B here is a hits algorithm, are finding different accounts in the top 20 because both of the algorithms working with different metrics or different heuristics. One of the observations that we found is all of the accounts ranked by the K-shell algorithm were citizen accounts, with fewer followers than all of the top 20 accounts in all of the other measures. For us, this means that most of the accounts at the core of the network are citizens because K-shell rank or give a higher rank to nodes at the core of the network, and we guess that the nodes at the core of the network are citizen account. And it is possible that the best influencer account is at the core of the network, and it is also possible that the second best influencer will not be at the core of the network. So we think K-shell is not optimal for identifying more than one super spreader. So it can be good in identifying the top one, but the next top one is not identified correctly by the K-shell algorithm because it gives more importance to all nodes that are at the core of the network. And here we extracted the top accounts from each algorithm. As you can see, for PageRank account, the most important accounts or the most important nodes in the network, 16 of them are verified accounts. And the top influencer account is media and news. And this is the categories for the top 20 influencer. 2 of them are government, 11 are media and news, 3 are journalists, 2 citizen, and 2 celebrity. And for your information, PageRank is, as I mentioned, is used by Google for ranking the searches over the internet. Hits algorithm also provided a competitive result, 14 verified accounts, and top influencer is Ministry of Health. N-degree, top influencer is also Ministry of Health. Closeness, Ministry of Health. Betweenness, Ministry of Health. K-shell found 0 verified account, as I mentioned, and top influencer is a citizen. Vote rank, it found 14 verified account, and Ministry of Health also is the top influencer, and these are the categorization. WCI find 18 verified account, and top influencer is government. Okay. So as a conclusion, this study identified influencer on Twitter in Arabic content of Twitter during the month of March 2020. We compared 8 of the major graph theory algorithms to identify influencers. So one potential work is analyzing the role of influencer in disseminating misinformation and whether they utilize their influence for the greater good of the society. So this can be our future work. And another line of research to build upon this work is analyzing information superspreader in other social platforms such as Facebook and Instagram. Thank you, everyone, and have a nice day. And if you have any question, you can send any of the authors on the email. Thank you.